first thing we have to do is to open up this JSON file programmatically and then load it in this dictionary data. And then the next step is to open up this new.txt file, which is going to contain our new data format. Then we're going to go through each and every title first. That's for this, that's data, because if we have the dictionary data, then selecting the option data will give us this list of all the different topics, and then we could simply find the length of this list, which in this case is equals 442, since we have 442 different titles. Then for each of these titles or each of these topics, we now have the different contexts or the different paragraphs. Recall that if we have this topic, for example, or this title Beyonce, we search, let's say, context, would have this first context, we have this next context, and if we keep scrolling, we'll have other contexts which will come up. So there we go, we see the different contexts that come up. And now this length here, the length of this data where we pick out a particular title and this paragraph, is actually the length of, or the total number of contexts or the total number of paragraphs we were dealing with. So here we have this total number of paragraphs, and then for each of those paragraphs we want to have the total number of question answers. Now once we do this, we could print out, let's comment this for now, and then we could print out the context, we could print out the question answer, that's the question, and then we could print out the answer to a given question. Now in order not to run all this, because it's quite a whole lot of different options, we could just have this one. So instead of having that, we just pick out one of this, and then right here we pick out one of this. Or let's say for this, for the context, we pick out one context, and then we'll let this, so we will have all the question answers for the very first context. After running this, we have this answer right here. We have the context, or the very first context, we have the first question, but for the answer we have this berg, because we told the string indices must be integers. Now actually what goes on here is we don't actually have a string right here, because if you look at the question, when we pick out a question, what we have directly is a string, but when we pick out the answers, we have this list made of the text, which now contains a string, and made of the answer stat that contains the character from which we start having the correct answer, or where this dangerously in love starts from. Now also note that we didn't use this, since we're not using a character-based annotation format. We're using word format to locate the position of this in the context. So that said, what we do is we select the first element in our list, and then we have the text. So we pick out the text, we take this off because we're selecting the answers. Then after running, what we get is this. So we have this Beyonce Giselle Knowles, that's the context. We have the question, and then we have the answer. Let's actually separate this so you could see clearer. So the separation right here, we have the context, we have the question, we have the answer. Here again we have the context, that's the same context. We have now this other question, and then we have the answer, and so on and so forth, right up to the very last question answer. So what we're going to do now is to put this in the line such that we could use TensorFlow's text line dataset from the tf.data package. So now we've understood this formatting, we could now write this in our file. But before writing it, let's also note that what we're going to be putting is not the answers, but instead where they're located in our text. So we need this get position method, which will permit us get the position of our first, or get the position of the answers in the context. Let's recreate the get position function. We have this. This function takes in the context that we have right here, and then the answer. So if we take this example where we have hello world, how, that, not, how are you doing, and then we have this answer, not, how are. So this is the position right here. and this. What we have to do is, firstly, we could convert this because we're dealing with tensors, so we convert this to a list. Then we take off any of this kind of character. We now go to the context length, so we go for each and every part of this context or this list right here. For each and every part of this list, what we'll be doing is we'll compare this with the values we get. So if we're comparing this hello with this, doesn't match, doesn't match, doesn't match, doesn't match, there we have a match. So once we have this match, we now increase this or increment this variable j. Once we increment this variable, we move to the next. If there is a match, we continue incrementing up to the point where the length of b, that's up to the point where you get to the end of the length of b. At the point where we stop, that's we come out of the loop, and then we return the value of this last position. Like in this case, we return this. This is our found, this is the last position, and then we subtract the length, because obviously if we have a given position like this, like if we found here, to obtain this position, it suffices to simply subtract the length of this. So that's why we have this subtraction right here. So we subtract that to get the start position. Now also note that while going through each of these elements, if we have, for example, like in this, if we have not right here, so let's have that, run it, we'll see that our algorithm solves the problem of maybe having a match which doesn't continue. Like here we have not how, but after this that doesn't match with the r. So what we do is we actually go through this, and if before getting to the end of our answers we don't have a match, or like in this case where we have dart which doesn't match with r, what we do is we set back our j to 0, such that once we get to this not, we're comparing this not with bbj or with the answer 0, and not with the current j which has been incremented already. So that's the reason why we have to do this. Now once we have this method, we are able to apply it right here. We have the answer, which is, for example, lead singer. We now come through this, so we get into the context, and then we get the position where our lead singer is found, and then where also it ends. So we get whether it's lead, and then whether it's the position of singer. Now once this is done, we now have the initial and the final positions. So we uncomment this, and then next we could go into writing this into our file. So write this into our file. We separate this by a tab. So here we have the context, and then followed by the question, followed by the init value, followed by the final value, and then we write this next line character. So for the first line we have this, for the next possibility, or for the next question answer, we go to the next line, and so on and so forth. So that's how we build this our new data format up. Also note that there are some answers, or there are some questions which do not have answers. In those cases, the answer will be, or will come up with this empty list. Now in this particular problem, we're not trying to solve this kind of examples where we could output that the question doesn't have an answer. So that's why we see here when we have this come up, we just simply pass. So we take only the answers which, or rather we take only the questions which actually have answers in the context. So right here we could uncomment this, we could simply command this, and then run this. After running, this is what we get. We see clearly we have the context, we have the question, and then we have the positions. So that just fine. Also notice that what we pass into this get position function is the list made of the string split of this context, and also this list made of the string split of those answers. And then before getting the position, we also pass through the pre-processed sentences for the two, that's the context and the answers. The reason why we're doing this is because supposing we have, say, I found a book, so we could have this. So I found a book today. Now the question could be, who found a book? So let's suppose we have, let's take this off from here. So suppose we have this. We have this context. I found a book today. And the question is, who found a book? Let's take this off. Question. Who found a book? With the answer being, for example, I. So our answer could be I. You'll see that in this case, saying that the answer is at position 0, that's the start position, and the end position is actually 0, 0, is correct because that's just what we have from here. Now, if we modify this to the book, let's put back this, the book was found by me today. So if we modify this to the book was found by me today, you have the answer me. Now the appropriate formatting will be 0, 1, 2, 3, 4, 5. So we should have now 5, 5. But this is going to be wrong because after going through the pre-processing before training, this is going to be taken off, or even if we don't want to take that off. So even if we have that taken off, and then if we had initially something like this, well, we're supposing that we had 5 because we had 0, 1, 2, 3, 4, 5. Now what we're gonna have after this, after the pre-processing, will be this instead. So now we're gonna have 0, 1, 2, 3, 4, 5 instead, and then me will be 6. So we'll be creating a data set which doesn't match with exactly what we get because this has been pre-processed, and that's why before creating this data set we have to pre-process it so it matches with the pre-processing, which is generally done before training the model on a data set. Now, since we've put our data in the line format in our txt file, we can now follow the similar process to what we've been used to doing already. So right here we'll define the number of examples, we've precise the location of our txt file, the validation. Then we have this tf.data.text line data set, which takes in the path and then the number of examples. We specify the byte size, and then we could now print out some elements of our text data set. Right here we have this, we have Beyonce, which is our Knowledge Carter, born on this, right up to the end, right up to this. Then we have this tab, which goes to the question, when did Beyonce start becoming popular? We have this other tab now, which gives us the first or the start position, and then this other tab which gives us the end position. Now the reason why we have this -3, 0 was just for test purposes, so we've modified that, and then we could even run other examples. Let's take, for example, 3. There we go. So with this now we have this examples here. We have the first one, we have the start, we have the end position. So if we count 40 or go to the 44th position, we are going to find the answers to our question. Then for this next one, we are 33, the 33rd position, and the 35th position. And then for this other one, we are the 93rd position. So we have 93, 93. So it just tells us that we just have one answer. And the question was, when did Beyonce leave Destiny's Child and become a solo singer? From here, we say the answer is 2003. And that matches up with the fact that here we have the same start and the same end. Our next step now is to map this text data set with this selector function, which explicitly separates each part of our data set. So we have the 0 to 1, that is the context. The next one is the question. The next one is the start answer, and the last one is the final answer. We also have this 0 to. The reason why we have this is because we want to create a vocabulary made of the questions and the answers, instead of creating a separate vocabulary when we could just join this into one. So if we run this, we could see some text data set now which has been modified. So right here we have this. So we've created this list. We have the first, the next. If we follow this up, we get to this point where we have when this is a question. So we have the context now, is quite separated from the rest. We have this list. We have now this other one when the question. The next one is the position, the start position, and then finally we end up with this ending position. And then we could go on to the last one, which is a mixture of the context and the question. And as we saw, the reason why we're doing this is because we want to create a joint vocabulary for those two. So again, here we have our pre-processed sentences. We define the context length, we define the question length. Now the questions are generally shorter than the context, so that's why we define this like this. Then we have this vectorized layer, which is now adapted based on our training data, where our training data is this value h, which we get. Now recall that here we had this to be x, so we consider this to be x, the next one to be y, the next one to be w, the next one from this we have x, y, z, so the next one to be z actually, the next one to be w, and finally here we consider this to be h. So we're returning this such that we are able to adapt our vectorized layer to the training data, which is made of both the context and the question. So let's run this, we adapt our layer, and then we could look at this vocabulary size right here. Then from there we have this vectorizer, which will permit us take the context and then pass it through the vectorized layer, take the question, pass it to the vectorized layer, take the start, convert it using 1 hot, and then take the end, convert it using 1 hot. So these two aren't concerned with the vectorized layer, whereas here we have the context and the question, which actually have to go through the vectorized layer. Note that we have two inputs, so we put them in this dictionary form. Then we have this other dictionary made of the two outputs, out 1 and then out 2. We run this, then we run to see some kind of output we get. So here, for example, we have this output. Now we have our vectorized output. We see the patterns because this context doesn't have up to 150 different words. We have now the question, which is also padded. Then we have this 1 hot representation of the start. So let's locate the 1. This should be located at like this. This is if we have to count this, yeah, if we have to count all this, we have 22 times 2, 44, and this position 45th position. But since we're starting from 0, it means this coincides with the 44th position, whereas this point here corresponds with the 47 because this is 44, 45, 46, 47, which matches up with what we have in our data set. And so actually what we're doing is we're collecting this context, the question, and then we're trying to predict which of these positions match up with the answer to the question. Note that these positions actually match with the context. Like here we have this shape 150, also with this shape 150, shape 150. So if we have a position 1, it simply tells us that if we come to the 44th position here, we shall get the answer or the start of the answer. And if here we have 1, it means if we come to the 47th position, we would also have the start of the answer. So that's how we look at this. Then finally we prepare our training data set, validation data set, and then we go ahead to prepare or to create these batches so that we can now train our model.